There are 5 operating limits governing a heat pipe's performance. These 5 limits affect how much heat can be transported from the evaporator to the condenser under any given condition. The limits are: viscous limit, sonic limit, entrainment limit, capillary limit, and boiling limit. What is the viscous limit? The viscous limit occurs at the lowest end of the operating temperature range of a heat pipe, where the vapor pressure difference between the condenser and the evaporator may not be enough to overcome viscous forces. These viscous forces slow down the vapor flow within the heat pipe. If the vapor from the evaporator does not flow to the condenser, the heat pipe cycle is discontinued, thus, no heat transport. The viscous limit that occurs within a heat pipe can be similarly illustrated by picturing a person that has accidentally fallen into quicksand or a swampy mud. The person does not have the muscle power to lift himself or herself up from the trap of the quicksand and is therefore stuck. What is the sonic limit? When traveling through the heat pipe vessel, the vapor leaving the evaporator could reach upwards of a Mach 1 speed of sound. However, reducing the vapor passage due to flattening of the heat pipe, or creating friction to bending of the heat pipe, or any variations in the heat input could all affect the vapor speed within the vessel. When the heat input is increasing, the vapor speed is also increased, thus building a larger pressure difference in between the evaporator. This faster moving vapor may be chocked by the slower moving vapor in front. This is sonic limit. The sonic limit that occurs within a heat pipe can be similarly illustrated by picturing traffic in a freeway. When the traffic in the front slow down, it creates a pile-up of traffic towards the back of the freeway that significantly lengthens the commute time from point A to point B. What is the entrainment limit? The entrainment limit refers to when the vapor flow strips liquid from the wick. If a heat pipe has insufficient vapor passage, the vapor traveling at high speeds from the evaporator to the condenser will strip the liquid upon its return and reduce the liquid rate that is returned to the evaporator. This causes the heat pipe performance to be reduced. The entrainment limit that occurs within a heat pipe can be similarly illustrated by picturing the strong winds that blow over a sea surface. When the wind blows, it draws the sea water up to the air with it. Flattened heat pipes or heat pipes with one or more bends are particularly affected by this entrainment limit. The narrower the passage, as with flattened heat pipes, or the sharper the bend, as with bent heat pipes, the greater the entrainment effect will be. What is the capillary limit? Capillary action, otherwise known as capillarity, is a manifestation of the surface tension by which the portion of liquid surface coming in contact with a solid is elevated or depressed, and is dependent upon the adhesive or cohesive properties of the liquid. Capillary action enables the liquid within the wick to propagate in all orientations. In a real-world application illustrating capillary action, you can picture the alcohol inside of a lantern as it propagates up against gravity, or a sponge as it absorbs water on a floor. A heat pipe would not be able to function at an against gravity orientation where the capillary action is not strong enough to move the condensed liquid from the condenser back to the evaporator. Or, in the case of a long heat pipe application, where the capillary action is not strong enough to propagate the liquid within the wick back to the evaporator. This is capillary limit. What is boiling limit? Boiling of the working fluid needs to be kept on the wick surface. If boiling occurs inside the wick, it will stop any supply of return liquid meant for the evaporator. If no liquid is returned to the evaporator, there can be no continuous boiling and the heat pipe will fail. The boiling limit occurs at the highest operating temperature range of a heat pipe. Heat inputs to the evaporator should be carefully designed to ensure they do not exceed this boiling limit.